Hi everyone, I am Dhanushkumar. I am doing my second year bachelor degree in SNS Institute of Technology in the Department of Agriculture Engineering. I am here to give a presentation about a case study of topic use of remote sensing and GIS in agriculture in the field of agriculture. Okay, next we will move to the topic. First, what is remote sensing? Remote sensing is a acquisition of information about a object or phenomenon without making a physical contact with the object. In modern usage, the term generally refers to a use of general sensor, aerial technology, to classify the objects based on both on the surface and in the atmosphere and ocean by the means of propagated signals like electromagnetic radiations from aircraft to satellite. Next, I have displayed images. This is the early motor sensing focuses. Next, we'll move to the case study. Agriculture drought is nothing but decline in productivity of crops due to irregularities in rainfall as well as decreased in soil moisture, which in turn affects the economy of nations. The purpose of the study is to analyze the vegetation stress in drought-prone districts by NVDA values and land surface temperatures such as like a LST. The combination of NVDA, normalized differences vegetation index, and LST provides very useful information for agriculture drought, helps to monitoring the yearly warning for help to monitoring and give a yearly warning from the farmers. By remote sensing, we can check the help of what fraction of the photosynthetical active radiations absorbed by the vegetation. The digital numbers of LSD data is converted into Celsius scale with the help of the formula. Temperature is equal to dn digital numbers into 0.02 minus 273.15 degrees Celsius. Next, we'll move to application of remote sensing in the field of agriculture. First, identification, area estimations, and monitoring. Next, crop nutrition deficiency detections, helps to soil mapping, crop condition assessment, agriculture drought assessment, and reflectance monitoring, crop yield modeling, and production forecasting. Next, I have displayed the process of remote sensing. Reference data, air photos, digital data is converted into visual digitals. Next, maps converted into maps, statistics, and GS data. Then it is transmitted to the users and decision makers. Elements of remote sensing. Energy sources. A denotes energy sources of illuminations, and B radiations and atmosphere. C interactions with the target. D recording of energy by the sensors. E transmissions, receptions, and processing. F interpretations and analysis, and G applications. Next, we'll move to geographic information system, GIS. It is a system used to design to capture, store, manipulate, analyze, and presents all the type of geographical states. It is a type of system which digitally makes and manipulates spatial areas that may be jurisdiction proposed or applications oriented, and it is a spatial data infrastructure. Next, I have given a flow chart of remote sensing techniques. Global navigation satellite systems, GNSS, and mobile proximal soil and crop sensing. They have divided into two types, like digital elevation maps and remote sensing. And digital elevations further developed into yield maps, clustering methods, management zone maps, and historical management data, calibration stress, soil sampling and laboratory analysis, interpreted thematic maps, etc. Next, we'll move to the conclusions. Remote sensing technology has been developed from balloon photography to aerial photography. Early identification of crops health and stress, improve the crop yields, reduce costs, reduce environmental impact, crop management to maximize the returns through seasons, and crop management to maximize the returns through during harvest times, and crop yield predictions. Thank you for listening for my presentations. Thank you.